Welcome to Module 9 on polynomial operations. Right now, pause the video, find a writing utensil and a piece of paper. A spiral-bound notebook is perfect for what you'll need for this course. If you need help getting a notebook, please let your teacher know today. Note-taking will be important so that you have access to what you're learning without having to re-watch all the videos. Plus, you can use your notes on the quizzes. Today we're going to be talking about polynomial operations, so you might want to write this down at the top of a new notebook page. Module 9 is on polynomial operations, which means essentially we're going to be adding and subtracting polynomials, multiplying polynomials, and squaring a binomial. We will not be dividing polynomials right now because you need to learn how to factor next time before we do that. All right, new topic, adding and subtracting polynomials. To add and subtract polynomials, combine like terms. So I want you to write that down, that you've got a new topic on adding and subtracting polynomials, and that you should be combining like terms. You also need to write down your definition of like terms. Like terms have the same variable and the same exponent. There's a couple of different ways to do this, but I want you to get out of the habit of thinking that parentheses always mean to multiply. You want to look at what's in front of the parentheses. In front of the parentheses is a plus. That's telling you to add to this whatever is in here. But I can only add things that are alike. So what I have so far is negative 5y squared plus 3y. Neither of those are like terms. They both have y's, but this one doesn't have a y squared, so they're not the same. It wants me to add to that negative 7y squared minus 6y plus 2. Notice that I've got all my like terms lined up now. Negative 5y squared and negative 7y squared, remember we're adding, not multiplying. I don't add the 2's together. This becomes negative 12y squared. I'm adding, not multiplying. 3y plus negative 6y is negative 3y, and then we just bring down the plus 2, and that's it. There are no more like terms, there's no equal sign, so we're done there. You pause the video and try this one on your own. So you should have started off with your first set of parentheses, 6y squared minus 5y minus 3, and we're going to be adding, not multiplying. So that means we're going to be lining up our like terms. We're going to add down the columns, 7y squared minus y plus 2, and you want to be careful about signs. 6 plus 7 is 13y squared. This is negative 5 plus negative 1. If you want to write that out to the side, it looks like this. So that's negative 6y. And negative 3 plus 2 is negative 1. There are no more like terms. There's matching y's, but they don't have the same exponent, so those are not actually like terms. If we need to subtract, that changes our signs a little bit. So we start off the same way. We look at what's in front of the parentheses. There's a minus there, so we're not actually multiplying, but we do need to distribute that minus, and I'm going to show you what that means now. We've got negative t squared plus 7t minus 5. And what I'm doing is subtracting everything that's in here, which means I need to change the sign of everything. Negative 4t squared, negative 3t, and negative 6, because a negative times a positive is a negative. A negative times a positive is a negative. A negative times a positive is a negative. I'm subtracting everything that's on the inside. If I do that, now I can just add down the columns. I get negative 5t squared, 7 plus negative 3 is 4t, and negative 5 plus negative 6 is negative 11. There are no more like terms. Even though there's matching t's, they both don't have the same exponent. You pause the video and try this one on your own. You should have started by writing down your first set of parentheses, thinking that you're subtracting, which means you're subtracting everything inside. But remember, that's going to change some of our signs. If I subtract a negative, it becomes a positive. If I subtract a positive, it becomes a negative. And if I subtract a positive, it becomes a negative. Now I just add down my columns. There's an invisible 1 there, so that's 8v squared. Negative 3v plus negative 5v is negative 8v, and 6 plus negative 4 is positive 2. I can't go any farther because there's no equal sign and there are no more like terms. Now, we're starting a new topic, multiplying a monomial, and this should say by polynomials. We're multiplying a monomial by polynomials. We want to distribute to do this. And now that we're multiplying, we can use our exponent rules. To multiply with powers, we add the exponents. So it says to use the distributive property to remove the parentheses. So essentially, we're using what we learned about our exponent rules last time to distribute. Remember, we multiply whole numbers just like always. So 10 times 8 becomes 80, but this becomes y to the 16th because I'm multiplying this time, not adding. 10 times 9 becomes 90. Don't forget there's an invisible 1 here, so y to the 8th times y to the 1 is y to the 9th. 10 times 2 is 20, and that's just 20y to the 8th. You also can use something that we call the box method to do this. If we have 10y to the 8th being multiplied by 3 things, I can make a box that has 3 sections. Sorry, I can't make a very neat box using this. So that's 8y to the 8th, 9y to the 1st, and 2. And I can multiply each of these things. 10 times 8 is 80. Y to the 8th times y to the 8 is y to the 16th. 10 times 9 is 90. Y to the 8th times y to the 1 is y to the 9th. And 10 times 2 is 20 with y to the 8th. Notice that's exactly what I have here. The box method is just another way to organize my work. I don't find the box method particularly helpful when I'm working with a monomial times a polynomial. You pause the video and try this one on your own. Whether you use the distributive property or the box method, you should have multiplied everything times 6y to the 7th. 6 times 2 is 12, and y to the 7th times y to the 1 is y to the 8th. 6 times 9 is 54. Y to the 7th times y to the 2nd is y to the 9th. And 6 times 6 is 36, y to the 7th. If you used your box method, you should have gotten the exact same thing. You just got to make sure you rewrite it with your pluses in the middle. Let's try those again. We want to rewrite these without the parentheses. Again, you can either use the box method or just distribute. This becomes positive 45 y to the 8th. Negative 9 times 7 is negative 63, and y to the 5th times y to the 1 is y to the 6th. And negative 9 times 3 is negative 27th, y to the 5th. You pause the video and try this one on your own. You should have distributed here. This becomes positive 45 y to the 4th. Negative 5 times negative 3 is positive 15, and we just bring down the y to the 3rd. And that's it. Now, multiplying binomials is different. So we've got a new topic, multiplying by binomials. Write that down and underline it. You don't need to write down to multiply a binomial times a binomial, but I would write distribute twice. Essentially, we have 2 things now that need to be distributed into w minus 1. If we had, for example, just w times w minus 1, we would distribute, and we'd have w squared minus 1w. If we had just the 5 times w minus 1, we would distribute 5, and we'd get 5w minus 5. But what we actually have is just both of these combined together. So we have w times w minus 1 plus 5 times w minus 1. And then we end up with some like terms in the middle. So we want to simplify those. Negative 1w plus 5w is 4w, and we bring down the minus 5. Some of you learned this as FOIL, first, outside, inside, last. We don't teach it that way because it makes some things harder later on, but that's essentially what we're doing. You pause the video and try this one on your own. Notice that you should have had 2 things being multiplied times u minus 3. We're both multiplying u times u minus 3 and 8 times u minus 3. So we're going to distribute each one. So we have u squared minus 3u plus 8u minus 24. U squared plus 5u minus 24, because we combined our like terms, and that's it. There is no equal sign, and there aren't any other like terms, so we stop there. All right, let's try this one again together. We've got 2 things being multiplied times 5y minus 1, so we're doing y times 5y minus 1 plus 4 times 5y minus 1. We're going to distribute our y, so we have 5y squared minus 1y, and distribute our 4. 4 times 5y is 20y, 4 times negative 1 is negative 4. This becomes 5y squared. We've got our like terms here in the middle. Negative 1y plus 20y is 19y, and we bring down the minus 4. There aren't any other like terms, and there's no equal sign, so we stop there. You pause the video and try this one on your own. You should have noticed that you had two things to multiply times 2b plus 1. So we're doing b times 2b plus 1 and minus 5 times 2b plus 1. We're going to distribute the b. That becomes 2b squared plus b. And distribute the negative 5. That becomes negative 10b minus 5, not minus 10. Oh, see if you can catch my mistake. What did I forget? There should be a b here because these will be like terms. That becomes 2b squared. 1 minus 10 is negative 9b, and then that's minus 5. All right, now, when we are squaring something, I want you to remember what it means. To square a binomial, we are multiplying it times itself. So you should write that in your notes. And I want you to remember that when I square something, for example, if I have x squared, that's x times x. Whatever is being squared, it's multiplied times itself. It works the same here. And remember, your parentheses group those together. It's telling you that we're multiplying 6b minus 5 times 6b minus 5. I cannot distribute my 2 because this isn't a multiplication problem, it's a subtraction problem. Exponent rules only work with multiplication and division, not with addition and subtraction. So now I should see that I need to do 6b times 6b minus 5 minus 5 times 6b minus 5. I'm going to distribute each one. 6 times 6 is 36. B times V. Now I can use exponent rules because I'm multiplying. I add those. B times V is V squared. 6V times negative 5 is negative 30V. 6V times negative 5 is negative 30V again. And negative 5 times negative 5 is positive 25. Those do not make 0. Put that into your calculator. Negative 30 minus 30 is definitely not 0. It's 36V squared minus 60V plus 25. You pause the video and try this one on your own now. You should have done 3 minus u times 3 minus u. You should not have distributed your exponent. So that means you've got two things to distribute. 3 times 3 minus u times 3 minus u. 3 times 3 is 9. 3 times negative u is negative 3u. Negative u times 3 is negative 3u. And negative u times negative u is positive u squared. The like terms are here. Again, that's not 0. Negative 3 minus 3 is negative 6u, and then that's plus u squared. Now, you can distribute any number on the outside of the parentheses last. So for example, I see that I've got these two things being multiplied together and all of that times negative 4. So I'm going to worry about the binomial first. So I'm going to make this c minus 2 times c plus 7. This becomes c times c plus 7 minus 2 times c plus 7. C times c is c squared. C times 7 is 7c. Negative 2 times c is negative 2c. And negative 2 times 7 is negative 14. This becomes c squared plus 5c minus 14. And then don't forget, we had a negative 4 times all of that. So now we just multiply each of these by negative 4. Negative 4c squared minus 20c. I don't know what 4 times 14 is off the top of my head, so I get my calculator out. A negative times a negative becomes a positive 56. You pause the video and try this one on your own. You should have started off worrying about your binomials first. You're doing each one of these times b plus 7. So we do b times b plus 7 plus 3 times b plus 7. That becomes b squared plus 7b plus 3b plus 21. That becomes b squared plus 10b plus 21. And then don't forget, all of that needs to be multiplied by negative 3, which is real easy to forget. I forget it sometimes. Negative 3b squared minus 30b minus 63. All right, multiplying trinomials. When you need to multiply something with 3 terms, that distributive property gets a little out of hand. You can definitely use your distributive property. you can see that you have two things that need to be multiplied by the trinomial. So you could do w times 2w squared minus 5w minus 6, and then you could multiply all of that times 7. But I often think that it is easier to work with trinomials with the box method. So when I set up my box method, I've got 3 terms in the first set of parentheses, and I'm going to put those along the top. 2w squared minus 5w minus 6. And then along the side, I have w and I have 7, and I'm going to put those along the side. Now I can just multiply, and I'll be able to find my like terms in these diagonals. So I'm going to multiply w times 2w squared, which is 2w to the third. I'm going to multiply w times negative 5w, so that's negative 5w squared, and w times negative 6, which is negative 6w. For this one, I'm going to multiply 7 times 2w squared, which is 14w squared. 7 times negative 5w, so that's negative 35w, and 7 times negative 6, which is negative 42. And then your like terms are along your diagonals, so you can simplify that way. So 2w to the third doesn't have any like terms. 14w squared plus negative 5w squared is 9w squared. Negative 35w plus negative 6w is negative 42w. And then the negative 42 doesn't have any like terms. That's the exact same answer I would have gotten had I distributed. It doesn't matter to your teacher which one of these methods you use, as long as you use one that works for you. You pause the video and try this one on your own. If you want to use the box method, I'll go ahead and set that up for you, and then you can try it from there. So I like to put my trinomial along the top, 6x squared minus 3x minus 7, and my binomial along the side. And then I draw columns down in between all the numbers. All right, you see if you can fill in your boxes from there. Pause the video and try that one on your own. So you should have done everything in the top row by 2x. So that's 12x to the third, because x squared times x to the 1 is x to the third. 2 times negative 3 is negative 6, and x times x is x squared. And 2x times negative 7 is negative 14x. Now we're going to do everything in the top row by 5. So that's 30x squared minus 15x minus 35. And then like terms are along the diagonals. So we have 12x to the third plus 24x squared minus 29x minus 35. Now, again, if I have to do a trinomial times a trinomial, I'm going to use that box method. It's going to help me organize my work in a way that starts to get a little overwhelming with all the parentheses. So I put my 3 terms along the top, and this time I also have 3 terms along the side. I draw lines between all of them. So you can draw straighter lines than I can. And then we're going to multiply. 4 times 1 is 4. X squared times x squared is x to the 4th. 1 times 2 is 2. X squared times x is x to the 3rd. Negative 5 times 1 is negative 5. And we just bring over the x squared. 4 times 4 is 16. X times x squared is x to the 3rd. 4 times 2 is 8. X times x is x squared. And negative 5 times 4 is negative 20x. Negative 6 times 4x squared is negative 24x squared. Negative 6 times 2x is negative 12x. And negative 6 times negative 5 is positive 30. Your like terms should be along the diagonals, and if they're not, you have an error. So for example, if this were a 2, I would know that I forgot something. So now I'm going to combine my like terms. My 4x to the 4th is the only x to the 4th, so I just bring it down. Positive 16x to the 3rd plus 2x to the 3rd is 18x to the 3rd. So those are taken care of. Negative 24 plus 8 is negative 16. Negative 16 plus negative 5 is negative 21x squared. So that takes care of all of our x squareds. Negative 12x and negative 20x make negative 32x. And then we just bring down our plus 30. All right, let's try one together on this one. I'm going to set it up for you, and then you try the multiplying on your own. So along the top should be 4v squared plus 2v minus 1. Along the side should be 2v squared plus 3v plus 5. We're going to draw our box here, make some rows, make some columns. All right, you see if you can fill in your boxes now. Go ahead and do that now. For this one, 2 times 4 is 8, and v squared times v squared is v to the 4th. 2 times 2 is 4, and v squared times v is v to the 3rd. 2 times -1 is -2, and we just bring over the v squared. 4 times 3 is 12, v times v squared is v to the 3rd. 2 times 3 is 6, v times v is v squared. -1 times 3v is -3v. 5 times 4v squared is 20v squared. 5 times 2v is 10v, and 5 times -1 is -5. Again, your like terms should be along the diagonal. If they're not, you know you've done something wrong. So that means this is the only type that's like that, so I don't need to worry about combining like terms there. For this one, 12 and 4 make 16 v to the 3rd. Along the diagonal here, 20 plus 6 minus 2, 20 plus 6 is 26, minus 2 is 24, so that's 24v squared. That takes care of all those. 10v minus 3v is 7v, so that takes care of all those, and we just bring down the -5. You're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 9 in ALEX. You should now complete Module 9 practice problems. Again, if you're having trouble finding those, you're going to click on Continue My Path. That's what you're looking for to do the practice problems. In the practice problems, you can always click on the explanation. You can also find this video again under Resources, or you should have your notes to look at. When you've done all of that, you want to go back to the home page by clicking on the circle with the 3 lines, click on Assignments, and then you're going to be taking Quiz 9, but not until after you do your ALEX practice problems. Thanks, guys. Have a great day.